Good afternoon, everyone. Thank you very much for joining this webinar. This is the second part of an introduction to Quantum GIS. It's very well-known open source GIS software. Now, I want to show you the most interesting part of this presentation, which is the use of imagery of a satellite called LandSat8. It's American satellite. It was launched 2013, but for Syria, the first picture are from 2015, and it has a very special camera. This camera is not just taking picture, but it's taking a series of pictures of different wavelengths. And not only that, the SWAT width of the picture is 185 kilometers. So you can see on the imagery, what does it mean, Swatch? So it means every 16 days, it can cover the whole Earth. It means that every 16 days, we have a picture of your area of interest. And this is very interesting. Like I was telling you, the camera is very special. It has a lot of different wavelengths. And the wavelength alone doesn't really tell you that much, but if you combine the bands in a certain way, you will have a different perception of the reality. Here you have the band combination for LandSat8. If you take, for example, the combination of band 4, 3, and 2, you will have a picture that somehow reflect the natural color of the situation. This is very good because it means every 16 days you can have a picture of the area of your interest. If you combine the bands 5, 6, and 4, you have a situation, a perception where water will be somehow emphasized. You can see all flooded area. This is very interesting because if you are identifying a new site and you want to know if the site is going to be flooded, you just take the picture of the past of the flooding period, and then you can see if the area is flooded or not. And then, of course, you have other combination. For us, site planner, maybe the false color 764 could be of interest because that there we can see how our site developed. The rest is more interesting for agriculture, for ecology, not that much for site planner, but still nice to have. The problem is that the resolution is not good at all. It is 30-meter resolution only per pixel. What does it mean? This means that we cannot identify a single shelter. We cannot identify a bridge. But on the other hand, we can identify an urban area. We can identify a big road, for example, a river. But for us, most important, we can identify flooded area or dry area. And this is where I want to go today. And at the very end, just to add that this is for free. So anytime, anywhere in the world, you can have a recent picture of your area of interest. There is a specific workflow, and I will inform you already in advance that it has a lot of steps. But that's why this webinar is going to be recorded. The slides are going to be available under the link under my YouTube channel, a YouTube video. And you have to follow this workflow if you want to have a proper result. In short, it works like that. First of all, through the earthexplorer web page, you identify the area of interest exactly like you did for the digital terrain model. Once this area has been identified, you have to define the period of interest. Let's assume that you want the flooding area of last year in April, so you can put the time from beginning of April to the end of April. Or let's assume that you want all the picture taking in March, just define, I want all the picture of March. And then optional, you can also define the maximal cloud coverage. The issue is that when we have the flooding, usually we have as well bad weather. It means we have cloud. So on the satellite, if we have cloud, cannot take any, I mean, it will take picture, but the picture will not be interesting because we are going to see only white. That's why you can optionally as well define the cloud coverage in percent. Once these parameters are defined, you just click on search or filter, and then you get all the picture that match to your parameters. You download the picture, you manipulate the picture, we are going to see how, you combine the bands, and then at the end, we will interpret the result. The next webinar will be part 3. We are going to vectorize the result, and we are going to develop a nice layout for your thematic maps in terms of flooding, which is going to be used for the report. But it is not going to be today because the webinar will be too long. So let's start like we did for the digital elevation model. And let's browse, or let's navigate to the area of interest. I take the same zipped shape file like last time. I click OK, and I have again exactly the 4 points of interest. My sites are inside here. Then next point would be, here I have the coordinates of the points. Next point would be to select or to give to the software the data range from where to where. You can just put data, or you can put a month. In that case, I remember I was putting just February, the month of February. So show me all the picture taken during the month of February of this area. And since the satellite take the picture every 16 days, if you choose 1 month, you might have from 1 to 2 pictures per month. But I didn't give any limitation in the time. I just tell them, give me all the months of February since the beginning of the life of the satellite. And the second step would be, what kind of picture do you want to have from this web page? So you go to select data. Previously, we were selecting the digital elevation model. This time, we are going to select LandSat because we take the picture from this LandSat satellite. Select on LandSat collection 1. Select LandSat collection 1 level 1 and LandSat8 only. This is the satellite that makes the picture with the camera that I just was explaining with the bands, several bands. Optionally, like I was telling you, you can put the land coverage, cloud coverage. If you don't put anything, it will just give you all the picture based on the selected period. But we don't want picture with too much cloud because clouds are not helping us at all. That's why we select at least 90% of the area must be clear. I can put even 100% of the area, but I put 90% because if I put 100% of the area during the month of March or February, the likelihood to have no picture is very high. So if you don't have any picture, you have to change your criteria a little bit in order to have some result. Or you can change the time, the extent of the time. Okay, once you have set the land cloud cover, you click on result, down there. And the system is going to give you all the pictures that are matching to your parameters. In my cases, I have 11 pictures. Now, which one is good? I don't know yet. But of course, I'm living in Switzerland. I have no idea about the situation in Syria, but you are working in Syria and you know exactly when occurs the worst flooding. So you choose the period of the worst flooding, hoping that you don't have too much cloud. But in my case, I just check everyone and I have to check how this picture looks like. Here you will have the date of the picture, in this case 2020 February 14. If you click on this icon here, you will just download the picture to your computer, all the bands. And if you download it on the bands, you have several options. You can download this GeoTIFF, and you see it's almost 1 gigabyte. It will take some time to do that, but this contains all the imagery of this period, of this very picture, and those imagery are geo-referenced. It means you open it in qGis and they are going to be on the right position, but still you have to check. Additional, you could as well download this one up there. It's just natural color images. It's very small, 7 megabyte, but this is not the geo-reference, but at least it shows the situation and it can give you in a very short moment the idea how much cloud and how is the quality of the picture that you are going to download. If you see that this picture is full of cloud, maybe avoid to download the gigabyte and go to another set of picture. So once you click on download, it will take time. The computer will not react the very few minutes. Don't be afraid on that. It's just the time probably that the software needs to select the picture. I don't know why it takes so much time, but after a while, you will see the download process will start. And of course, 1 gigabyte, don't do it with your mobile phone, do it in the office and take your time. Once you have downloaded the pictures, it will be on a zip format and you have to unzip it. And this is a typical presentation when you unzip it. So you see you have all the bands here, band 1, 2, 3, up to 11, but we are working only up to band 7. And then you have 3 additional files that we are going to use, this one and this one. So you have to save the unzipped version of these pictures in a file, in a directory that you name accordingly. Just put the name of the directory, like for example, LandSat8, and then raw file and the data. At this point, we have downloaded the imagery from the satellite, and we need to install in our qGis a plugin, which is called semi-automatic classification plugin. It is a very powerful plugin because it managed to work with most of the satellite pictures, not only Landsat, but as well Sentinel. But this we are going to see another time. So how to download or how to install the plugin for qGis? You go to plugin, manage and install plugins, and then you search not installed, and you write here SCP, semi-automatic classification plugin, and then you will get these 2 options. Just click on the right one and click on install. In a very few seconds, the plugin is going to be installed in your qGis. It's a very easy process. And this process works for all other type of plugins. Now, your qGis will look a little bit different. 3 new items appears on your screen. You will have a new menu, which is called SCP. You will have a new toolbar, like in the picture, and you will have a new panel, like you can see in the picture. For the moment, we don't use the panel, so you can, let's say, deactivate the panel. If you deactivate the panel, it is still going to be in your qGis, but just not visible. But the menu and the toolbar we are going to use. Fine. Now at this point, we can load our imagery that we have just download. We can load them into qGis. How to load the imagery, raster images in qGis, we have seen it before, exactly like the digital terrain model. You click on this icon here, open Data Source Manager, or we can also click Ctrl-L. You browse to your location where you have saved your LandSat8 imagery, and you select just the band 1 up to 8, sorry, up to 7. The rest you don't need to load. 1 up to 7, and you click Open. And then automatically those 7 bands are going to be displayed grayscale per default. We don't need to change the default or the style of this band yet. Now, first thing that you have to do is to check that they are at the right location. You can zoom in and zoom out, and as well to verify that the projection is corrected. Again, if you are working with a raster on the wrong location, your decisions are going to be wrong. And when you zoom in, you can see if the area are on the cloud or not. You can see here, these two sides are fine, but those are on the cloud. So for these two sides, our imagery can be used. Fine. Once you are happy with your imagery, we have to crop this imagery because it's much too big. And if we don't crop the imagery, the process time or the analysis time will take too much time. And most probably your computer is going to crash. Therefore, we have to crop all this satellite imagery. And there is a way to do it. You go, first of all, on your menu SCP, click on band set, and automatically, I forgot to tell you, in your qGis, you might have not only your imagery of the satellite, but you might have as well other raster file like OpenStreetMap and Google Satellite in my case. If you want to do things smooth and easy for the beginning, it's better you take them away, but it's not mandatory. You can keep it, but the system will be a little bit more complicated, but still feasible. So in that case, I took it away. I leave only the imagery of the satellite, only in terms of raster. In terms of vector, you can leave whatever you want, it's not a problem. So back, you go to the menu SCP, band set, and this mask is going to appear. Clicking on refresh list, all the raster file that you have in your qGis are going to appear. Sorry. Now, if you still have your Google Earth imagery, also Google Earth imagery is going to appear here. It's not a problem, but just be aware that all the raster images are going to be there when you click reset. Once you have clicked reset, you have to select only the files that you are interested on. In that case, band 1 to 7. Clicking on this icon, you automatically select everything. If you have Google Earth, you select just the 7 bands manually. And then you click on plus here, and automatically the 7 bands are going to be displayed on here, and a new band set is going to be created, which is called band set 1. You can have several band sets, but I advise you to work with one band set only in order to avoid confusion. Okay, this is now there. The band set 1 is created. And now it's time to crop those band set. You go again on this SDC menu, but this time you don't click anymore on band set, but you click on clip multiple raster. Under pre-processing, clip multiple raster. You have to be sure that you select the band set. In that case, we have only one band set, so you cannot make any mistake. In case you would have several band sets, you have to choose the right one, but I advise you to keep only one so you avoid problem. Then you can as well put a prefix if you want, clip or not, it's up to you. And then here with the plus, you have to define the area of interest where you want to clip. Click on the plus, then you can go back on your qGis. Just with the left click, you can start the left corner of the rectangle. With the right click, you can close the rectangle on the bottom. You can still change the shape of your area of interest. And then automatically the coordinates of the border of interest are going to be displayed. Another way, the way that I prefer, is to use a vector. Of course, you need to have a vector delimiting the area of interest. This vector needs to be in qGis. It doesn't need to be in a zip form. Just choose the vector with this drop-down menu. If the vector is in qGis, it will appear automatically. And then automatically the area of interest where you want to clip or to crop is going to be displayed. And you click run. Clicking run, first thing they will the computer will ask you where do you want to save the cropped area of the band set. For that, you need to create a new folder. You need to select the new folder. I call it clip LandSat and I put a date and OK. And automatically a new set of bands is created, saved on the location that you have specified in advance, and automatically displayed in your qGis. So exactly the same layer, but cropped. So it means the original one, the big one, you can now remove from your qGis. You remove it, select it first, right click on it, remove layer, and OK. Now we have the same situation like before, with the difference that the imagery of the satellite are cropped. I hope so far is clear. I know I'm going a little fast, but don't worry. When you look at the tutorial later on YouTube, you will be able to follow step by step and to do the job for yourself. So fine. Now we have the imagery of the satellite, of the data of interest, of the area of interest on your qGis and georeferenced. Fine. Now you go back to SCP menu and go back on band set. You refresh the list and you will have this time the cropped band set here, exactly like we did before. Now we clear the previous band set in case you didn't have it with this icon. It's empty. And like before, we select all the 7 band set, cropped band set, and we add them we add them again here like we did before. So it's the same steps, but only with the cropped band set. Still 7 band, fine. At this point, we have to convert the raster in reflectance. Exactly, I don't know what it does mean technically, but the thing is that we need to give the opportunity to the computer to mix, or to, let's say, to put together the band set. And if you don't do the conversion in reflectance, computer will not be able to mix the band set and to see the water, for example. So this is now the step to convert the raster in reflectance. What we do, we first select here wavelength quick setting. We choose LandSat8, the satellite that we take the picture from. And if you see, this satellite consider the band 2 up to 7. Band 1 is not considered anymore. Don't ask me why, but band 1 is not there anymore. This is important to keep in mind. Then select the right dimension, micrometer, and optional, not important, you can select the date of your picture. It is, I did it wrong, but fine. It is February 27. Then you click run. And then what next step would be, you go on pre-processing, you go on LandSat, and then here, at this point, you have to select the directory where you have saved the cropped bands. Here you have to select the original directory where you have downloaded the original Landsat file, the raw one. If you remember, there were many imagery and 2 or 3 text file. So you have to choose the text file with the extension MTL. Then you click on apply DOS1 atmospheric correction and you click on run. Now the reflectance has been done and the files, now when you click run, the computer will ask you where do you want to save the new reflected imagery. For that, you open or you create a new folder, you call it reflectance, for example, and the date, and as well you give a name, and then automatically, once you have clicked run and the analysis finished, you will hear a sound when the analysis is finished. It can take some time, and then you will have a new set of bands with a prefix RT reflectance here. And if you can see, band 1 is going to be missing here. Okay, fine. Now we have 6 bands prepared for our analysis. You delete again the files, the cropped file that you have used before, in order to avoid misunderstanding. You don't delete them, but you just remove it from qGis. You select it, right click on it and remove. And once it's removed, you go back on your semi-automatic classification plugin and you click refresh. Now you will have the 6 bands, which are the reflected bands. Only 6. Band 1 is missing. You clear the previous band set and you select the 6 band. You click on plus and the 6 bands are going to be added here. Now we see a small discrepancy. You see that line 1 has the band set number 7. Sorry, so here, line 1 has the band set number 2. Line 2 has the band set number 3. And this might create confusion when you mix the band set, when you combine the band set. That's why you should do with these two arrows, you should take band set 7 and push it up to line number 1. So you know that only band set 7 is on the line number 1. The rest are on the corresponding line. You see, band set number 2 is on the line number 2. Band set number 3 is on the line number 3, except band set number 1. But this we can keep in mind. Okay, fine. You click run, and the process will start. At the end of the process, you will hear a beep. Fine. Now it's actually over with the processing of the band set. Now we can start to display our imagery, and we can start to combine our maps. Here you have the combination possibility. Let's start with natural color. It is band set 4, 3, and 2. Here on the top, where you have this mask, you have to write 4/3/2 and enter. And then you have this imagery. You see, it's an imagery with the combination 432 of this specific date, February of 2020. Bad resolution, but at least it can show you, you can understand a little bit the size of the site, for example. You can eventually increase the brightness. You can a little bit change, like we have seen with the digital elevation model, the color. You can change a little bit the style of your raster. This you do as you have seen before. But the good thing is that this imagery is very recent. Here, how to change with F7, you can change the style. Especially important is this one. Change the brightness. It may really gives you more or less information. And here you can see band 3, 4, and 4, 3, and 2 mixed. And yeah, you can a little bit play around and see what result gives you the best layout. And now let's go to another combination. The combination is to identify the water. So combination for water would be 5, 6, and 4. You go here, you click 5/6/and 4, enter, and then you see how clear you can see the river, really clear. These black spots are actually the shadow of the cloud, so it's not a river. But here, for example, you can see the blue. This is as well flooding. This is the situation in February 2020. So you could see part of the site here was flooded. You can zoom it, of course, and you can see clearly a flooded area here. This is shadow. You can clearly see the river. And this for any period of the year up to 2015. This is a very big advantage. Now, the problem is that you do this process for one date, for one images, but we have almost 2 images every month. So maybe that you have images of better quality. That's why you should do this process for several images, so several period of time. Maybe not only February, but also March and April. And then you should compare the result, of course, and work with the result of better quality. I give you 3 examples here. I did flooding experiment for Kafr Aruk site in April 2015. And you could clearly see a stream going through the site before actually the site was open. If I would have had this information before opening the site, I would have preview a nice drainage because I would have known where the water is going through. We didn't have this information before. We didn't do the drainage. That's why it is now every year flooded. This is another example. I did the same workflow on the 27th of March, and it was cloud. So this is actually useless for me. So I would throw away this image or this date. Here I did the same process on the 1st of March 2020, and the quality is very bad. So yes, eventually you could get some information out of it, but it's not that clear like this one. And then another example here, Sarmada. The same in April 2015, it was very clear. One river was passing through, plenty of flooding here. And this would be a very useful information before doing a drainage. Additional, you can see this blue line here. This is the watershed analysis done with the digital elevation model with the global mapper like you have seen previously. So if the digital terrain model, if the watershed analysis match somehow with the images of the satellite, we have a proven information that the flooding that I can see on the satellite is correct, or we have the proven information that the simulation with global mapper is correct. Here, the same Sarmada picture during March 19, cloud, useless. And here, the same Sarmada picture, another date, quality is not that good. I don't know why it's not that good image, but it is like that. So that's why it's important to have this analysis done on several dates in the period of interest. And then, of course, you need as well to compare your result with Google Earth, for example. You see here, we have the flooding and then the Google Earth satellite. You can somehow identify the stream here, and somehow you can see even on Google Earth where the water was passing through. So clearly, if you have to open a site in Sarmada, now it's too late, but before open it, here should be an area where you have to put your drainage. And that's important as well to have on your global map, on qGis, several background imagery like Google Earth, Yandex Map, Bing Map, and then to play back and forwards and to see. So like you see, this is a very performing process. You can have a lot of information, but still the interpretation needs to be done by you only. You will not find a legend who tell you exactly what is this color for. You have to interpret it yourself, what is the red for, what is the blue for. And now maybe, okay, next workshop, I will show you how to vectorize this different raster color and how to produce a nice thematic maps, flooding map that can be used for the report. Now I want to switch. I want to switch on my qGis just to play a little bit around on the result. Let's take the result, which actually is the best one, the result of 2015, this one. Here you see Sarmada, for example. Sorry for my voice, some water. Now we are in qGis.
We can't see the picture you are mentioning.
You can see.
We are still on the PowerPoint.
Okay, in that case, I stop share and share again. One second. Where is the mouse here? I share again the screen. Share screen. I think it's this one. Let me see. 1920. This one. Okay. Now you can see the screen?
Yes, we can.
Okay. Now you see the blue dots are the natural stream done with the watershed analysis in Global Mapper. Here we have Yandex satellite. Let's take Google satellite, which is more precise. We have the Google satellite that you can find online. We don't know the date of the Google satellite. And here we have the virtual band set. The virtual band set is the layer where you display the combination of the band. Now, let's take the combination of the natural color, for example, which is 432. 432. Okay, it's not that much natural in this case, and quality is not that good, but you can eventually play around maybe with brightness a little bit to see if it improves. Yes, it's improved a lot. You can see, okay, this doesn't give you that much information, but let's take the water situation, band 5, 6, and 4. Band 5, 6, and 4. This is the water. We can clearly, I go back, now I go back again here. Okay. Here you can clearly see for Sarmada where you have the flooding. You can see the flooding here. You can see the other side. This one is probably this blue is flooding, this blue is flooding, this is flooding. Let's go another side. You can clearly see the river here. And let's see another side. This one maybe. Okay, here also you can clearly see that there is a river going through. We can go to another band side. Let's try to urban false color. Urban, it would be band 764, but if you remember, band 7 is 1. It has been changed to 1. So what I'm going to type 164 in that case. 164. This should show the urban area of the urban places. So okay, you can see everything what is built is kind of white, but you have to be careful with the cloud, of course. If you have cloud, it's also white. So you can play around with all those bands and see the different result. Let's go to another example. Let's go to first this one. This is now March, 1st of March. Let's go to water, 564 band. 564 water is this one. You can clearly see the water here, the river here.
Sorry, you are not showing the
oh, sorry.
Correct one. Instead of stop sharing and start sharing, you can share your screen. When you click on share on the green arrow, you can ask for share your current screen, and then you whatever you open, you share.
Okay, but you are screen sharing. I don't have this command. New share. Okay.
Yeah.
And then
stop sharing.
Yes.
Now, yeah, new share.
New
and
share.
Share your current screen, and then
Fine.
Everything you open, yeah, clear.
Okay. Now you can see that. You can see now the new screen.
Yes.
Okay, fine. Now you see again. I choose the band combination 564, which is for water. Very clearly, I see the water here. It's a river. And also here by Atme side, very clearly, not really very clearly, but somehow I could detect the flooding. Everything what is kind of blue is flooded. If you don't see properly, again, change maybe a little bit the brightness. Maybe you can see better. Now here you don't see properly. Let's see on this one, not really properly. But here, for example, we have, I have no idea what is it, but we have the river here, a big channel, obviously a man-made channel, and a big flooding here. People who knows the area will recognize this big lake. I have no idea what is it. But it's clearly seen that we have a flooding here. And of course, if you have this picture in front of you, and if you know the situation on the spot, it will be very easy for you to identify the location of trouble. Let's go to another site. Let's see this one, Sarmada. Here you have clearly flooding here. The channel is still there. You have a big flooding somehow here in the middle, and somehow big flooding here. So you can see the power of this analysis with LandSat8. Kafr Aruk, not that much flooding at this day, probably, and so on. So now the issue is that before opening any site, I think it is mandatory for any site planning to check the location in terms of flooding with LandSat8, checking all the months of the past and see if the site was flooded or not. Additionally, you make a terrain analysis, you make a watershed analysis, so you know more or less where the drain has to be done. And only after this analysis, you can start to develop your site. You can start to first put your drainage system, and after that, the road and the shelter. Doing like that, you minimize the risk of flooding. Now, that's it. I think my presentation is over, and I hope that you got an idea about the power of the LandSat8 imagery. And also, I really hope that you are going to use it in the future for any new site. Of course, if the site is already there, you have just to mitigate the mistakes done previously. But for the future site, I think it's mandatory to do that. And I will push the shelter cluster to ask for it before opening a new site. And this presentation is quick, in 1 hour. It's not easy to follow all the steps, but you know that I'm here and I will help you, assist you, and coach you to do whatever you ask me to do in terms of analysis. And now it's time for question. And thank you very much as well for listening to my voice for such a long time. I will wait 1 minute. If there is any question or any suggestion, please go ahead. And you know that by tomorrow you will have this webinar online on YouTube. The presentation will be as well on YouTube. My contact is on YouTube as well, and please do not hesitate to contact me.